Hi guys, and welcome back. So now that we've got this brand new cluster named Wonderful Monster here, we're going to go ahead and set up the cluster autoscaler on this particular cluster. So if I head over to EC2 here and I take a look at my autoscaling group, you can see that right now the default configuration for EKS CTL is to set the autoscaling group to 2 instances as a desired capacity, as well as the minimum and maximum. So at the moment, this particular autoscaling group is not going to be allowed to scale up. And so one of the things that we'll need to do is make sure that we edit the configuration of the autoscaling group and increase the maximum capacity, let's say maybe 20 nodes here, and that will allow us to add additional nodes to the cluster by using the cluster autoscaler. So make sure that you do that. You don't necessarily have to do that first, but if you do install the cluster autoscaler and you see that it's not scaling kind of according to your expectations, then that could be a potential problem that you might need to go rectify separately. All right, so now let's go ahead and find the documentation here for autoscaling. And so again, you can just go ahead out to your favorite search engine, look for autoscaling for your particular cloud provider. Of course, in this case, we're using EKS. So I'm going to be using the EKS documentation. Now, there's quite a bit of manual setup work that's going to be involved in order to provision the cluster autoscaler. So basically the way that this feature works is it creates an IAM policy and a role. So the policy is basically a set of permissions that are going to be necessary for the cluster autoscaler feature to actually call out to the EC2 autoscaling APIs and manipulate the configuration of the autoscaling groups. In particular, there's an API in AWS called autoscaling set desired capacity, and as the name implies, that is how the cluster autoscaler feature running on the cluster itself is going to be able to call out to AWS, and basically you could find that autoscaling group that's running as part of our node group that we provisioned through EKS CTL, and it can call this API set desired capacity and increase or decrease the number of nodes in the cluster, as we saw happen in the previous video, where we kind of ran through a sample of what could happen when we deploy additional pods and we start to exceed our cluster's capacity. So then once we've created that policy definition using this policy template right here, we'll create an identity and access management role. And this role is essentially an application identity that the cluster itself, well, in this case, the cluster autoscaler specifically, can use. And basically any permissions that are granted to that role by this policy that we define are then going to be used by the cluster autoscaler in order to call out to the AWS APIs. So it's a lot of kind of identity work here that we need to do in order to set it up. But then once we do that setup work, we can deploy the cluster autoscaler itself. And this is a fairly simple process. You know, it's if you've ever used kubectl to do a deployment of any Kubernetes resources before, it's very similar to that. So we've basically just got a Kubernetes manifest here that has the cluster autoscaler, and you're going to see it's actually being pulled directly from GitHub. So you're going to go to the master branch, which is the cutting edge branch. You're going to basically go to the Kubernetes autoscaler repository, and you're going to find that AWS specific autoscaler feature. And then once you apply that YAML file to your cluster, there will be a couple of additional setup steps here in order to create an annotation that points over to the role that we create. So we basically have to tell the cluster autoscaler which identity and access management role that we create earlier is going to be used to actually call out to the APIs. And then one of the other things that we'll do here is run a patch to set another annotation here. And this is basically saying that the cluster autoscaler itself is not a safe component to evict. So if that cluster autoscaler is running on one of the nodes in the autoscaling group, the cluster autoscaler should not evict that pod from running on that node and therefore potentially compromise the integrity of the cluster autoscaler pod itself. And so that's done by setting a special annotation called the safe to evict annotation. And then you'll basically just edit it and add in a couple of command line options here. So you're basically just going to pass in those command line options to balance across different node groups, and then also to skip over any nodes that are running system pods for the Kubernetes cluster, so that we're not compromising the integrity of the cluster. And then down here, the final step is to basically set the specific patch version number for the version of the cluster autoscaler that we want to run. And as we discussed in the very first video, I think it was, there's basically we want to make sure that we're running the corresponding version of the cluster autoscaler for our actual Kubernetes cluster itself. So we'll go ahead and grab that and then set that. And then once you do that and the autoscaler is fully up and running, then you can go ahead and run a logging command here to actually get the logs from the autoscaler, and you can actually see the kind of event loop that it's going through, and it's just running every 10 seconds approximately and making decisions about whether it needs to increase or decrease the number of nodes. So let's go ahead and get started here. So one of the very first things that we're going to be doing is creating this identity and access management policy. Now you can use the AWS CLI or other SDKs to create this. In fact, they have AWS CLI commands that you can use here. I'm just going to go ahead and use the AWS Management Console though to create this for the time being. So what we're going to do is create this policy here called EKS Cluster Autoscaler Policy. So let's head over to our AWS Management Console. We'll go over to IAM here, and then we'll go down to roles. And I've already created this, or actually policies, and then I've already created this policy for my other cluster. So let me just do a search for EKS here, and I'll also filter for any just customer managed policies. Let's see, let me find the name of it. So it's EKS Cluster Autoscaler Policy. Do a search for that. And then, oh, it looks like I didn't actually create it, or maybe I created it with a different name. Yeah, maybe I created it with a different name. So, okay, we'll do create policy, and then we'll go ahead and just grab this policy text here, and we'll plug in the JSON here. So we'll just select the default JSON there and then just paste this in. And then we'll go ahead and do the name. So I'll paste in the name of that, which is Amazon EKS Cluster Autoscaler Policy. Delete that trailing space, and we'll hit create policy right down here. And then once we've created this policy, we need to create the actual IAM role itself and attach this policy to that role. So the role will have the permissions that were defined in this particular policy here. So we'll go ahead and find that over here in the EKS CTL utility here. So what we're going to do is call out to EKS CTL, and then we're going to plug in the name of our cluster. So we're going to have to find the name of the cluster. We can use EKS CTL to do that, of course. You can also use the AWS APIs to find that out, and you'll plug that in for the cluster parameter here. And then you'll also be needing the ARN of the policy so that you can attach that policy to the newly created IAM role. So let's go ahead and copy this command, and I need to make some edits to this, so I'm going to put it into Notepad for now here. And what we want to do is find the ARN for this policy. So let's head over to the console here again, and we'll copy the ARN for that policy that we just created, and then we'll come back here and just paste that in. And then for the cluster name here, we could use the console to find that out as well. Let's do EKS. Head over to the EKS service, and then you can also use EKS CTL to find this out as well. You can just do an EKS CTL get cluster, but I'm just going to go ahead and copy this cluster name right here and plug that in. Make sure we don't have any trailing spaces here. And because I'm in PowerShell, not using Bash, I can't use these backslashes as line continuation characters. PowerShell actually uses a backtick as the line continuation character, so I'm just going to change all of those to backticks. And this should work okay here. So I'm going to go ahead and copy this, bring it over into my shell here, and we'll just paste it in and run this command. So the other thing that I need to add in here as well is that I have a custom credentials profile set up locally. And if you have that on your system, you can just do profile and then the name of the credentials profile inside of your AWS credentials profile. As you can see, this command actually failed here. It says no IAM OIDC provider was associated with the cluster. And of course, I totally forgot there's actually a section right here in these bullet points here under prerequisites where you have to set up an IAM OIDC provider. So let's go ahead and open that up, and we can use the AWS command line utility to, first of all, find the OIDC provider URL. So let's go ahead and run this command over here in our console. Let me plug in the name of my cluster right here, and then we'll go ahead and just hit enter here. Of course, I need to specify my profile again, CBT, and here's our OIDC provider URL. So now that we've got that, we can go ahead and just list it in AWS to make sure that it actually exists. So first we were kind of just querying the cluster, but we need to make sure that it actually exists in AWS. So let's do an AWS IAM list and see if it's in there. And I'll specify profile CBT again. And then you can see in this list here that it does not actually exist. So I've got one with A2156, but the one with A0682 does not exist. So we're going to have to go ahead and create that. And to create that, we can actually just use the EKSCTL command line utility. So we'll just run EKSCTL utils, associate IAM OIDC provider, specify our cluster name, and then approve. And of course, I need to do my profile CBT on there as well. So let's paste in our cluster name here. I'll grab that here and paste, and we'll go ahead and associate that. And it's going to go ahead and create that. And then just to verify that, we'll go ahead and run AWS IAM list again to list the OpenID providers. And now you can see the OIDC provider with A0682 has now been created in IAM. You can also verify that in the console too, by the way, just so you know. If we head over to the console, go over to the IAM service again, there's an OIDC connection here, identity providers, and right here you can actually see the list of identity providers. And so when we run those command line tools, we're actually basically just querying this exact same information. So if you'd prefer to use the console, you can certainly go this route instead. So now that we've created the OIDC provider, we can go ahead and rerun this command right up here that actually creates the IAM role for our cluster. So let's hit the up arrow a few times, find this big old command right here, and we'll go ahead and try to rerun that again. And this time it should create our IAM role, and it's actually going to do that through CloudFormation. So it's actually doing that by creating a new CloudFormation stack right here for the cluster Autoscaler, and it'll just wait for that to complete. And you can of course verify that over in the console as well. So if you go to CloudFormation, we can open up the CloudFormation console here and then go over to our CloudFormation stacks. And there should be a brand new stack here for Wonderful Monster, and here it is. So this is the CloudFormation stack that contains the cluster Autoscaler role. And if we take a look at the resources here, you can see it's literally just an IAM role. Nothing super special here, but for whatever reason, EKSCTL likes to create it using the CloudFormation stack instead of just doing it imperatively, which is probably a good practice because then it makes the cleanup a little bit easier to handle. All right, so let's head back over to our documentation now. So now that we're done with OIDC, we can close that. And let's scroll down a little bit here. And now we're going to deploy the cluster Autoscaler itself. So we'll do that in the next video. I hope this has been informative for you, and I'd like to thank you for viewing.